Back to Introduction to Power BI. In the previous session, we completed creating the dimension region table, right? Where we had the country ID, country, and the region columns. Let me just share my screen. Yeah. So we basically created the dim region table using, codes data set that we connected to and the two tables that we created, right? So the region names for the expanded names of the continent codes and the missing country IDs in the codes data set, right? So basically we had this issue where these 6 rows in the dim region table did not join with any of the rows, or basically it did not have a matching row in the codes data set. The reason is because these 6 country IDs were missing from the codes data set. So basically we manually determined the region or continents for these country IDs, right? And then added this information to the codes dataset, and then we had a perfect match when we merged dim region with codes dataset in order to borrow the region column from codes dataset and have it as a third column in the dim region table. Okay, so right now we have completed creating the dim region table. So now we have to complete creating the other two dimension tables and the fact table or the central table. Okay, so before we proceed with creating the other two dimension tables, we are basically we are basically done with creating the dim region table, right? So we don't need these 3 data sets: codes, region names, and added regions. So what we can do, we can select them. Okay, we can select these 3 data sets, right click on any of the data set, move to group, and move them to the source queries. Okay, so select the 3 queries here: codes, region names, and added regions. Right click on any of these 3 data sets, move to group and source queries. Okay, because we have completed the dim region table. Remember when we saw the difference between reference and duplicate, we had basically created 2 copies of population 2010-2040, right? Where first we looked at the reference option and then next we looked at the duplicate option. So anyway, we had to create a copy of population 2010-2040. So we already have that, right? In case if you have not created a copy, or if you're not able to see this, what you can do, you can right click on population 2010-2040 and select either the duplicate option or the reference option. It doesn't matter. Okay, anyway, we are not going to make any changes in the population 2010-2040 dataset, right? So it doesn't matter if you select duplicate or reference. Okay, so in case you have not created a copy, okay, we had already created in the, I think in the previous session. So we can use this for dimension age table. Okay. Okay, coming back to the presentation here, let me just open the presentation. I'll share the presentation today. Okay, so I have made the change where I have added the region column also. Okay, why is this not opening? Yeah, it's open here. Okay, if we come to this, yeah, so I have added the region column here. So in the dimension age table, we need 3 columns, right? Age group ID, age group, and category. All we have right now is the age group column. Okay, so we need to add 2 more columns in the dimension age table, that is age group ID and category. Okay, so I will explain you a little bit about the age group ID and category columns that we have to create. Okay, in the dim region table, in this case, we already had country ID and country. So we would basically we were only able to we should able to create only the region column, right? So we were supposed to only create the region column, but here we only have 1 column, but we have to create 2 more columns. So coming to age group ID, so what exactly is that group? Basically, the age group ID column will have a unique value or a unique ID for each age group. Okay, so we have 21 age groups, right? 0 to 4, 5 to 9, 10 to 14, and so on. So each age group should have a unique ID. So that is the purpose of the age group ID column, where each row will have a unique number, starting from 1, starting from 0, or starting from any number you like. Okay, so that is the concept of age group ID, and basically the gender ID also. So the age group ID or the gender ID column will have, the rows will have unique values or unique IDs. Okay, and coming to the category, so what exactly is the category column? So the category column is nothing but based on a particular age. right? Based on a particular age, we are going to define a category. Okay, so for example, if the age is less than or equal to a particular number, let's say 4 or 5, okay, then we are going to call this we are going to categorize this as a baby. If the age is less than or equal to, let's say, 14, okay, then we are going to categorize it as a child, and so on, right? So we have 6 categories. Okay, I have already defined what should be the category and the criteria to create that category, but how exactly we can create that, we will see that next. Okay. So coming back to Power Query Editor, so the first step here is to rename this file here, right? So let us rename this particular file here to dim age. Okay, dim dash age. Then the next step is to basically remove all the unnecessary columns. Okay, so coming back to the presentation, we only need 3 columns here, right? Age group ID, age group, and category. We already have age group, so let us retain only the age group column. Okay, let us retain only the age group column and remove all the other columns. Okay, so let the data load here. So until it loads, I'll not be able to, basically make any selections in the file. I mean, in the query here. Excuse me. Yeah. So now we have renamed the file. Now let us remove all the other columns except age group. Okay. So the easiest method is to select age group, go to remove columns, and select the option that says remove other columns, so that Power BI retains the currently selected column and removes all the other columns. Okay. So select age group, go to remove columns, and select the second option, remove other columns. Okay, so that only age group column is retained and all the other columns are removed. Now, so basically we'll be repeating, a couple of steps that we applied in while creating the dim region table. Okay, so where we removed the columns, then removed the duplicate values from the column, right? So those steps are similar. Okay, those steps are the same when creating the dimension tables. Okay, be it dim age or dim gender, we'll be repeating, a couple of steps. Because the purpose that we had, multiple occurrences of each age group or each country ID or country is because for the different years and different genders, right? So now that we have removed all those data, it doesn't make sense to have duplicate data, right? So that is the purpose we remove duplicates from the column. Yeah.
Why we are preparing another file like dim age? Previously we have dim region. There is a so why we are preparing now age file?
So because we need a separate table for the different aspects in our data sets, right? So that is the purpose of applying a multi-dimensional star schema, right? So where you split one table into multiple tables where each table has a different purpose, right? So that you're organizing your data sets in a structured and logical manner. That is the purpose of creating and establishing a data model in Power BI, right? And that we are establishing through the multi-dimensional star schema concept. Okay, so that is why we are creating 3 dimension tables and 1 fact population table.
Okay, so after that we have to prepare gender table.
Sorry. Yeah, exactly. So after okay, where's the presentation here? So after we create dim age, we'll create dim region, dim gender or the dimension gender, and then the central table or the fact population table, which will have the so-called foreign keys from the dimension table and some quantitative information in the form of year and population. Okay, so then we'll go to the next concept called as relationships, okay, or cardinality basically. So then we'll have a look at the data visualization concept. Okay.
Okay.
Yeah. So now we have removed all the other columns except age group. So the next step would be to remove the duplicate values, right? So to remove the duplicate values, there are two ways. You can right click on the column and select remove duplicates, or you can select the column, go to remove rows and select remove duplicates. Okay. Can't see screen. Okay. Is everyone else able to see the screen?
Yeah.
Yes, we
Okay.
can.
Let me do one thing. I'll just stop sharing and start the sharing again, so that if there are any issues, it should it should be rectified. Are you able to see now?
Yes.
Okay.
Yes.
Yes.
Okay. Cool. So now let us remove the duplicates from the age group column. Okay. I will choose the second option where I select the column, go to remove rows, and select the option remove duplicates. Okay. So I think we should be left with only 21 rows, meaning we have 21 unique age groups. So after we remove the duplicates, we will create the category column. As I said, the category column will be based on a certain age. Okay. Now here we have a range of age here, right? 0 to 4, 5 to 9, 10 to 14, and so on. We have the minimum and the maximum age. So for creating the category column, we'll have to extract the maximum value. Okay, we will extract the maximum value from the age range, and based on a condition applied on the maximum age or that particular column which has the maximum values, we'll define the categories. Okay, so we'll be creating a conditional column, because the category column will be created based on a condition applied on another column. So when we create a column which is based on a condition in Power BI, it is called as conditional column. Okay, or creating a conditional column. That is what we are going to do next. Okay, so let the data load here. Okay. Yeah, so now we have only 21 rows here, right? You can confirm that in the bottom left of the screen, or you can see these these row numbers here, right? So now excuse me guys, I'm getting a sneeze. Okay, just a minute. Me. Yeah, sorry for that. So right now we have to extract the maximum values. Okay, we've already done that, right? So basically we just have to select the extract text after delimiter. Okay, so what we have to do anyway, we want to retain the age group column, but we still want another column which has the maximum values from these age ranges, right? So we can duplicate the age group column, right? So you can right click on age group column and select duplicate column. Okay, so then remember, in text after delimiter, for the 100 plus value, we got blank values, right? So when we applied the extract text after delimiter, and where we specified the delimiter as hyphen, because that is the delimiter specified for all the values except 100 plus, right? So when we applied the text after delimiter for the 100 plus value, the 100 plus value was basically a blank value. So instead, what we can do, we can replace 100 plus with dash 100. Okay, so we'll be replacing 100 plus with dash 100 in the duplicated column, so that when we apply extract text after delimiter, and we would be specifying the delimiter as hyphen, right? So when you apply text after delimiter for dash 100, the value you will get is 100, right? So that is the logic why we are going to replace 100 plus with dash 100. Okay, so I'm going to show you. Okay, so let the column populate here. Excuse me. Yeah, so now what we can do, we can rename the column first. Okay, let us rename this as age group max, and then the next step is to, before we apply the text after delimiter, let us replace the 100 plus value with dash 100. Okay, so that when we apply text after delimiter, and the delimiter we specify would be dash, right? So instead of a blank value, we would then get 100, and all the other maximum age, values from these ranges here. Okay, so the next step would be to select the replace values option here. Okay, so select age group max, select replace values. So value to find would be 100 plus. Okay, 100 plus, and we are replacing it with dash 100 or hyphen 100. That's it. And click on OK. So now when we apply the extract text after delimiter for the 100 plus value, since we have replaced it with dash 100, we would not get a blank value. Okay, we would just get 100. Okay, so that is the logic of why we are replacing 100 plus with dash 100 or hyphen 100. So let the replace values option complete here. Once we have replaced 100 plus with dash 100, we will go to transform and apply extract text after delimiter. Yeah. So now we have replaced 100 plus with dash 100. Now we can go to transform. Make sure that you have selected age group max column. Okay. Go to transform, and in the text column of the ribbon section, select extract and text after delimiter. Okay. Then specify the delimiter as dash or hyphen and click on OK. So that we will basically have only the maximum values from these age ranges, and 100 plus is basically, we decided to keep it as 100, right? Because after 100, there are infinite numbers, right? So it doesn't make sense to have multiple values for the the 100 plus category. Instead, we could just keep it as 100. Okay. So now based on the values that we get here, or basically based on the maximum values of the age range, we will apply some condition. Okay, we'll apply some condition to define the category. Okay. So now we will get basically 0-4, we'll get 4, from 5 to 9, we'll get 9, and so on, right? Now, based on these values, we will apply a logic or apply a condition to create the category column. Okay, so but before we do that, we have to change the data type of this column, right? So right now we do not have a range anymore. All we have are numbers, right? So change the data type of age group max column from text to a whole number. Okay. So then we can proceed with creating that conditional column. So to create a conditional column in Power BI, we have to go to add column. Okay, we have to go to add column and select the option just below the menu here, right? You can see that there's this option called as conditional column. Okay, so right now we have changed the data type of age group max column to a whole number. Now to create a conditional column, go to add column in the main menu here, go to add column and select the option that says conditional column. So if you read the description, it says create a new column that conditionally adds the values in the currently selected column. So basically you will be applying a condition on the currently selected column and defining the values to be present in the new column that we are going to create. Okay, so select age group max column, go to add column and select the option that says conditional column here. Okay, now here in the configuration window, first you have to define the name of the new column that we are going to create. So let us call this new column as category. Okay, category. And here the condition is based on if else logic or if else clause. So I'm sure most of you must have at least heard about these conditions, right? If else conditions. So basically we'll be taking or applying this if else logic on one column, right, on a particular column, and defining the values, right? If the condition matches, what should be the value in the new column that we are going to create. So that is the logic we are going to apply here. So we created this age group max column, right? So we are going to take into account values present in the age group max column, apply a certain operator, okay, such as, if it is equal or if it is less than or equal to, or if it is greater than equal to, or, the other operators, and define a value here. Okay, and then if this condition matches, if age group max, let's say if age group max is less than or equal to 4, then we are going to categorize or basically have the value in the category column as baby. If the age group max is less than or equal to, let's say, 14, then we are going to call it as a child. Okay, and so on, right? So that is the condition we are going to apply to create the category column. And the condition is if else conditions. Okay, if else, if else, if else. And notice that in any platform that that you use the if else conditions, the if else clause or the if else statements should always end with the else. Okay, so the else part here is basically if the condition does not match, then what should be the value. So that is the purpose of having or basically ending an if else statement with the else clause here. Okay, so now let us begin applying the condition. Okay, so we are going to apply the condition on the age group max column, and the operator we are going to use will be less than or equal to. Okay, so for all the conditions. Okay, so the first condition is that if from the drop down menu select age group max, because that is why we created this age group max column, right, to apply the condition on. So if the age group max is less than or equal to 4, okay, is equal to 4, then what should the output column, or basically what should the category column say, or what should the value of the category column be? So let us call this as a baby. So basically the first row would say baby here in the output or basically in the category column. Okay, now let us move on to the next the next age value. Okay, so how do I add another clause here? Just click on the button that says add clause. So basically it will be else if, right? So right now the first condition is if. Then if this particular condition does not match, then what should be the second condition? And that is basically else if, right? If else, if else, if else. Okay, so now the second condition, else if age group max is less than or equal to, let's say, 14. Okay, so now the range forms, right? So the first condition, it was less than or equal to 4. Then for the second condition, we are saying if age group max is less than or equal to 14. So now the range would become 5 to 14, right? Because the first condition is done with. Basically, we have executed the first condition. And Power BI or any other platform for that matter, it always goes through the first condition first, then the second condition, then the third condition. Okay. So right now it forms a range, right? So right now the condition for the first clause is that if it is less than or equal to 4, so the range would be 0 to 4. Then we specify the condition saying if age group max is less than or equal to 14. So now the first condition is already executed. So now the range would form, right? So it would be 5 to 14 now. Okay, because it is less than or equal to 14. Now if it is less than or equal to 14, it is basically all the values that is equal to 14 or less than 14. But since the first condition is already executed, right, so it won't go beyond 5. Okay, it won't go below 5. Okay, so it will create a range now, 5 to 14. So we are going to categorize this as a child. Okay, or let me just connect my charger. Okay, I'm running low on battery. Just give me a minute. Okay. So don't worry about the values that we are taking here and the categories we are defining. I know 14 is not considered a child but a teenager, right? But let's not worry about the categories that we are defining here. Okay, but let's focus on the logic that we are applying here. Okay, so the second condition is that if age group max is less than or equal to 14, then we are going to categorize it as a child. Then let us come to the next category. Okay, click on add clause. So basically this part remains the same here. The column name and the operator part remains the same for all the conditions. Okay, so else if age group max is less than or equal to, now let's select another value, 34. Okay, so if it is less than or equal to 34, now the range would be 15 to 34, right? For the third condition, the range would be whatever values that are between 15 and 34. We will categorize it as a uh, sorry, not 34, 24. Apologies. Okay, so the third condition, the value should be 24, not 34. Okay, so if age group max is less than or equal to 24, we'll let us categorize it as a teenager. Again, I know the ages after 19 are not considered teenager, but let us not worry about that. Okay, so the third condition is that if age group max is less than or equal to 24, we'll categorize it as a teenager. Now let us add another clause for the next category. Okay, if age group max is less than or equal to 34, we will call it as, or we'll categorize it as a young adult. Okay, and then the next category, if age group max is less than or equal to, now let's skip ahead. Okay, 64. Okay, let us type the value as 64. If age group max is less than or equal to 64, we will categorize it as an adult. Okay, now for the last category, we don't have to create another clause here because we have the else condition here, right? So basically if you hover to this information button for the else condition, basically it says when none of the rules are met, specify an output value or reference another column to output. So basically the else part is if none of the conditions above are met, what should the value in the output column be? Okay, so let's say none of these conditions are met. What should be the value? So instead of having another clause for that, anyway, we have to end the if else conditions on else, right? So that is why the else condition or the else clause is specified separately here. Okay, so now let's say none of these conditions meet or none of these conditions are satisfied. What should the value be? So let us call this as a senior. Okay, now we know the reason why we have selected these values is because we know these values are present in the age group max column. So all these conditions will be satisfied. Okay, so the reason why we are specifying senior here is because once all these conditions are satisfied, there are still values that are, sorry, there are still values that are greater than 64, right? Basically 69, 74, 79, 84, 89, 94, 99, and 100. So what should be the value or what should be the category for these values? That is defined by the else part here. So let us call all the uh, let us categorize all the ages that are greater than 64 as a senior. Okay, so whatever values that comes after 64 in the age group max column, they will all be categorized as senior. Okay, so this is the conditions that we have applied to create the category column, and the condition we have applied is basically the if else condition, and it is applied on the values present in the age group max column. Okay, and the operator we have selected is less than or equal to for all the conditions here, right? So if age group max is less than or equal to 4, we will categorize it as a baby. If age group max is less than or equal to 14, we will call it as a child. If age group max is less than or equal to 24, we will categorize it as a teenager. If age group max is less than or equal to 34, we will categorize it as a young adult. If age group max is less than or equal to 64, we will categorize it as an adult. And basically whatever values that comes after 64, we will categorize it as a senior. Okay, now we can go ahead and click on OK. Okay. So now the category column will be created and you can see the respective values here. So for the first row, it will say baby. For the 9 and 14 values, or basically for the second and third row, the category would be a child. For the fourth and fifth row, the category would be a teenager. For the 6th and 7th row, the category would be a young adult, and basically from 8th row till 12th row, it would be adult, right? Sorry, from 8th to the 13th row, not the 12th row. Okay, so from 8th row to the 12th, 13th row, it would be adult, and from 14th row onwards, or basically from 14th till 21st row, the category would be senior. Okay, so that is what we are going to see now. Yeah, so that is what we are seeing here, right? So the first row, it is baby, because if the age max is less than or equal to 4, we categorize it as a baby, and that's what you can see here, and the other values here, right? So basically all the values that comes after 64, right? So basically from 14th row onwards, the category is senior. Okay, excuse me. Now the next step is to change the data type of category column to a text, right? Because these are all text data, right? So change the data type of category column from this undeterministic data type to a text data type. Okay, so this is how to create a conditional column in Power BI. Okay, so the conditional column is always based on the condition if else logic or if else statements, and you apply the condition on one column and create another column. Okay, so you always apply the if else logic on an existing column. Okay, and based on the condition you specify, you determine the values to be present in the new column that you are going to create. Okay, so that is the logic, or the or the underlying logic of how you create a conditional column in Power BI. Okay, so basically we have created the category column. The last column that we are left with is the age group ID column, right? So as I said, the age group ID column is basically a column that contains unique values for each row. Okay, so basically the first row is 1, the second row is 2, the third row is 3, and so on. So basically you'll be assigning a unique ID or a unique number for each of the age groups here. Okay, that is the purpose now. Okay, so basically we'll be creating the age group ID column to assign a unique number or a unique value or a unique ID to these different age groups here. So how can we create how can we create a column which has unique values? So it is called as an index column in Power BI. Okay, so below the conditional column, okay, we are still in the add column menu. Below the conditional column, there is this option to create an index column. So if you read the description of the index column, so basically you create a new column with an index starting at 0. I mean, you have an option to create a new column with an index starting at 1 or a number of your choice, and you can also determine the increment. Okay, so basically if you click on this downward arrow here, you get 3 options. Okay, whether the value, or basically whether the new column should start with 0, or whether the value should start from 1, or you can also customize it. So when you click on custom here, basically you get to determine the starting index, or basically from which number you want to start the index column from. Okay, so let's say I will select 1 here, and the increment is basically what should the other numbers, or what should the corresponding numbers be. Now let's say you only want to have odd numbers to be present in your index column, okay, such as 1, 3, 5, 7, and so on. Now the increment here would be 2, because if you select the increment as 2, basically 2 will be added to the starting index, okay, and the corresponding numbers, right? If you add 2 to 1, what you'll get 3, so that will be the value of the second row. And similarly, if you add 2 to the second row value, that is 3, what you'll get 5, then so on, right? So 1, 3, 5, 7, 9, and so on. So that is the increment logic here. Basically, if you want only even numbers, you start your index with 2, and the increment would still be 2 here, right? So that you'll get all even numbers. If you add 2 plus 2, you'll get 4. If you add 4 plus 2, you'll get 6. If you add 6 plus 2, you'll get 8, and so on, right? 2, 4, 6, 8, 10, 12, and so on. But here, let us not bother about this. Okay, let us not bother about this. All we need is a column that has unique numbers starting from 1. So basically serial numbers, right? 1, 2, 3, 4, 5, 6, and so on till 21. Okay, because we have 21 rows. So what we can do, we can go to add column, select index column starting from 1. Okay, so select the second option from 1. so that the first row would say 1, the second row would be 2, the third row would be 3, and so on. Since we have 21 rows, the column would be from 1 till till 21. Okay. Yeah. So now this is basically an index column. You can see that, right? The first row says 1, the second row says 2 till 21. Okay. So now basically we have created an ID for each age group, right? So age group 0 to 4 will have the ID 1. Age group 5 to 9 will have the ID 2. Age group 10 to 14 will have the ID 3, and so on, right? So now we can rename this index column as age group ID. Okay. Age group ID, and move it to the beginning of the table. Okay, so basically you either drag this table like this, or you go to transform, make sure to select the age group ID column. Okay, you go to transform, and under the move option here, right, it is present in the any column section of the ribbon section. You click on move and select to the beginning. Okay, now we have created the dim age table also. Okay, and do not delete the age group max column, right? If you delete the age group max column, the values will basically you'll get an error in the category column, because the category column was created based on a condition applied on the age group max column, right? Now, even though in the dimension age table we do not have the age group max column, don't worry, because if we remove age group max column, basically the values will disappear in the category column. So retain the age group max column. Okay, because otherwise the category column would say error for each row here. Okay, so now we have completed the dimension age table also. So the last remaining dimension table is the dim gender, and the dim gender is the simplest dimension table that we you can create, because we already have gender. All we need is the gender ID column, and we know how to create an ID column, right? By creating an index column. Okay, so let us do that. So here also we need to replicate this population 2010-2040. You can right click on the data set, and you can either select duplicate or reference. It doesn't matter. I'm going to select reference. You guys can try duplicate. It doesn't matter. Okay. So now let us rename this table as dim gender. Dim gender. Just guys, just a minute. Okay, just a minute. Yeah. Yeah. So now we have created this. I mean, we have replicated the population 2010-2040. So the first step would be to rename the file, right? So let us rename it to dim-gender. Then the next step would be to remove the unnecessary columns, right? So when you look at the data set, all we need is, So all we need is gender ID and gender. So from this table, let us remove all the columns except gender column. Okay. It's still loading. Yeah. Okay. So you select gender column, go to home menu, and under the under the remove columns option, select the remove other columns. So you retain the currently selected column and remove all the other columns. So we'll be retaining the gender column and removing all the other columns. Okay. Yeah. So now the next step would be to remove the duplicates, right? Because we have only two genders, right? Female and male. So since we do not have that, the other data, the reason why we had these repetitions was because for different years, different age groups, right? At different countries, obviously. So we can remove the duplicates from the gender table. Okay. So I'm going to select the first option where I right click on the gender column and select the remove duplicates option. And the next step, you have these values as population female, population male, right? Instead, we should have it as just female and male, right? Because gender means male and female, not population male, population female. The reason why we got this value is because we unpivoted the male population and male female sorry male population and female population columns together. That is why we got this values here. These values are nothing but the column headers, right? So instead, what we can do, instead of population female, let us have just the term female, and instead of this term population female, let us have only the population male. Now, there are two ways to do it. Okay, there are two ways to arrive at only female and male as the values in the gender column. The first way is to basically use the replace values function. Okay, so you basically replace population female with female and replace population male with, you replace a population with just the space, okay, just the blank value, right? So then I will show you. Okay, so you click on replace. So basically the value to find would be population space. Okay, because there's a space between population and female, right, and population and male, right? And you replace it with blank. Okay, you do not replace it with anything. This is the first way. If you click on OK, you can see what the result would be. So basically we are replacing the population space with a blank. Okay, we are not including any value there. So basically we will get female and male as the values. Now the second way, can anyone tell me how we can arrive at the same solution but in a different way? We have already used that option. So apart from replace values, where we replace population space with nothing, so basically that population space was deleted, right? So that was removed, and you get female and male. Now let's say you didn't have this option. Okay, let's say you could not use the replace values function here. So which other option could you use to replace the population space part with just the blank? And note that we have already used this option, but for a different purpose.
Conditional.
No, exactly. We use the delimiter part, right? Text after delimiter. Kunal Sen is absolutely right. So basically, you go to transform, right? You go to extract, and here you select text after delimiter and specify the delimiter as population space. That's it, right? So you go to transform, extract, and select text after delimiter and specify the delimiter here as population space. Sorry, population space. That's it, right? And you click on OK. So basically, population space would be treated as the delimiter, and the text after the delimiter is female and male, and you only get the female and male values. Okay, so this is basically the second way of extracting or basically retaining only the female and male values from this particular terms here. Okay, female population female and population male. So you can choose either method. Okay, anyway, you're going to get the same result. So you can choose either the replace values option or the text after delimiter option, and make sure to specify the value as population space and not just population, because then you will have this trailing white space before the F and M here. Okay, so now we have extracted only the female and male part here. And now this makes much more sense, right? Instead of having the population female and population male values, it makes sense to have only female and male because these are the genders here, right? Now then the last step would be to create the gender ID column. And this is simple, right? You go to add column, click on index column and starting from 1. Okay, so that the a unique ID would be assigned to female and male values. Yeah. So now the female is assigned the ID 1 and male has been assigned the ID 2. Okay, and let us rename the index column as gender ID. Okay. So now we have completed creating the dimension tables, right? Dim region table, dim age table, and dim gender table. So we are done with the dimension tables. All we are left with is to create the fact population table. So again, we have to replicate the population 2010-2040, then make sure that we have these 5 columns. That is the foreign keys, right? Country ID, age group ID, gender ID, and quantitative information in the form of year and population. So let us do that. Okay. So let us go back to Power Query editor, replicate the population 2010-2040. Again, you can select duplicate or reference. Okay, I'm going to select the duplicate option now. So let us rename this table now as fact dash population and wait for the data to load. Okay. Then again, we have to repeat the same step where we remove the unnecessary columns. So in the fact population table, we should have 5 columns, right? Country ID, age group ID, gender ID, and then year and population. And right now, if you notice in our data set, we have country ID, we have year, and we have population. All we need is the age group ID and gender ID from dim age and dim gender tables respectively. So how can we do that? We can use the merge function, right? We can use the merge queries function in the home menu to borrow age group ID from dim age table and borrow gender ID from dim gender table. Okay. So right now we do not need the country column here, right? We already have the country ID. So we can remove the country column. Okay. So right click on the country column and select remove. We need year column. Now we don't need age group min column. Okay, let us retain age group column because when we merge dim age and fact population table, we need a matching column between these two tables, right? And since we already have age group in the fact population and we have age group in the dim age table, okay, so we have to retain age group in the fact population table because we will need it as a common column or the matching column when we merge fact population with dim age. Okay, so retain age group column, but you can remove age group min column now. Okay, so remove age group min column from fact population table by right clicking on the column and selecting remove. Here we need gender. Okay, because when we merge fact population with dim gender table, we need a common column to basically borrow this gender ID column, right? So retain the gender column in fact population. But here again, we have to change the values here, right? It is saying population male, population female. Instead, we should have male and female because if you merge these two tables and select the gender as the common column between these two tables, the value should remain the same, right? If the values are not the same, then the merge will not, basically it will not work properly. So in the fact population table, let us repeat the same step where we extracted only the female and male values from population female and population male columns. Sorry, values. Okay. So go to fact population table, select the gender column, go to transform. I mean, you can also use replace values. Okay. So let us use that option instead now. Okay. So we have already used the text after delimiter. So let us use the replace values function now. Okay, so select gender column, select replace values, and values to find would be population space, replace it with nothing. Okay, click on OK. Make sure to specify the space here. Okay, and click on OK. And we need the population data so we can retain the population data. All we removed were age group min and country columns. Okay, so now guys, just give me a minute. Just give me a minute. Okay. Yeah, sorry for that. So now we have, only the female and male values here. So we can go ahead with, merging the fact population table with dim gender table. Okay, so first let us borrow the gender ID column from dim gender. So basically we have to merge fact population with dim gender, then select the matching column as gender. Okay, so select fact population table, go to merge queries and select merge queries. So here you get a preview of the fact population table. We have already, done this process, right? So now from the drop down menu, select dim gender. And here we have to select the common column. So the common column is gender in both the tables, right? So in fact population table, select gender, and in dim gender, select gender. And it should be left outer here. Okay, so the join kind should be left outer because we are adding information to the fact population table. So we need this table to retain all its rows. Okay, so let us wait for the confirmation if we have a perfect match or not. Similarly, we will merge fact population with dim age to borrow the age group ID column. Okay, so then we will be done with applying the star schema to our data set here. So this will take a little bit of time because remember we had, I think, close to 260,000 rows in this table here, right? So we did not remove any duplicates, remember. So that is why it will take a little bit of time. No worries. Excuse me. So now the statement says the selection matches 259,098 of 259,098 rows from the first table, meaning we have a perfect match. Right now we can go ahead and click on OK. So now basically you get the entire table as a column and you have to select which columns you want to borrow. Okay. So you repeat the same step for merging fact population with dim age table. That's it. Okay. You basically, it's the same step. Yeah. So basically you expand the columns here by clicking on this expand button here and selecting only gender ID. Okay. And you can also deselect this option because instead of having the table name along with the column name, you can just have the column name. Okay. Make sure to uncheck this box also and select only the gender ID column and click on OK. So wherever female is present, it should say 1, and wherever male is present, that row should say 2. Okay. So once we extract, once we basically have these values populated, we can delete the gender column. Okay, because we have, the gender column, why we retained was because it was a matching column between the dim gender and fact population tables. So now that we have borrowed the gender ID column, we can go ahead and delete the gender column from fact population table. Yeah, you can see that here, right? Female is 1 and male is 2. So we can go ahead and delete the gender column now. Okay, right click on the gender column and select remove. So similarly, we have to repeat the same step for fact population and dim age merging. Okay, so you select fact population, go to merge queries again. Here this is an internal bug in Power BI. Sometimes you will not get a preview here. So what we can do, we can basically refresh this fact population table once. Okay, so to refresh a particular table, select that table in the query part of the ribbon section. In the query part of the ribbon section, you can see this refresh preview, right? So click on the refresh preview option. Okay, so basically it refreshes the table. So after refreshing, I think it should work. The preview should basically populate in the merge queries configuration window. So it's still loading. I mean, if you get that error, right? If you don't get that error, you need not, follow these steps. Or basically, you need not take this particular action. If you're not able to see the preview, then you basically have to refresh the fact population table, because you can see that there is this, this notification symbol here, right? So it means that, it's asking us to refresh basically, so that the data is up to date. Yeah, so now we have refreshed our table. So now make sure to select fact population table, go to merge queries and select merge queries. Now it should work, right? So now here we have to select dim age table. Now from the drop down menu, select dim age, and here the common column is age group, right? So select age group in fact population and also select age group in dim age, and let us wait for the confirmation. Okay, so the join kind should be left outer again. Yeah, so now the selection matches 259,098 of 259,098. So we have a perfect match. Okay, so we can go ahead and click on OK. And basically you expand the table and select only age group ID. Okay, age group ID. And then you can delete the age group column. Okay, so that is the last step basically. So after we expand the columns, or basically after we select the columns, you can delete the age group column. Okay. So then we'll be done with the fact population table as well. Yeah, so basically you click on the expand button and deselect all the columns and select only age group ID. Okay, and click on OK. So once the column is populated here, you can go ahead and delete the age group column. Okay. So we'll stop then and make sure to save the file. Okay. So on Monday, we will move to the next part of Power Query, that is establishing relationships between the dimension tables and the fact population table. Okay.
I just wanted to know what